class. Today we're looking at rectangles and their different properties. So a rectangle is a specific type of quadrilateral that is also a parallelogram. So I'll just write down that it's a type of parallelogram, but it's a very specific type. It's a type that has 4 right angles. So the reason why it's so important to say that it's a type of parallelogram is because all of those properties of our parallelogram from the previous lessons apply. So the opposite sides being parallel, or the opposite sides being congruent, the opposite angles being congruent, the diagonals bisecting each other, the consecutive angles being supplementary. I think we made a list of like 5 things. All 5 of those things still apply, but now it's just the specific type where it also has 4 right angles. So I'll just write down that all the properties of the parallelogram still apply. And if you'd like to go back and just copy those down onto here, you can. I'm not going to spend the time for this lesson to go back and do that, but you are more than welcome to. Really, as long as you know it has 4 right angles and is a type of parallelogram, you'll be all set. So then what we have is we have a couple of extra things that we know about these when it is a rectangle. So not only do the diagonals bisect each other like they do for any parallelogram, but now those diagonals are actually going to be congruent. So the diagonals in a parallelogram are congruent to each other, meaning they are the same length. And the way you usually see that in the picture is because it's really hard to like say that the whole thing and put a congruency mark on there, but you would just see it look like this. So those are the same, and then when you add them up, it's also going to be the same as this. And if I put some letters on here, this rectangle, I could say that RC is congruent to ET. Those diagonals are the same length, and you might have some algebra problems that you have to solve because of that. You might also have something like maybe this one is 2x and this part's 14. Well, those little parts are also going to be congruent to each other, so you could just set those equal to each other and then solve for x that way. We'll do a lot of practice of this. I think it'll come pretty quick to you. So one thing about these rectangles is you're going to be able to find all of the angles if you're just given one of them, and it doesn't really matter which one they start you out with. Let's just say that this angle right here is, I don't know, I'll make it up, let's say that it's 65 degrees. So that is this angle there. Just knowing that one angle, I can come up with every single other angle in this picture. And there's different ways that this can be done, there's different orders that you can do it, but you're going to have the same answer each time. So because this is a rectangle, these are actually different sets of isosceles triangles. If I'm looking at this triangle here, this isosceles triangle that's kind of turned on its side, these 2 angles are going to be congruent. So that's going to make each of those angles 65 degrees. And then if I know that those are both 65, I can add them together and take it away from 180 to get this angle over there. So when I add those up, I get 130, and then 180 minus 130. This angle is 50 degrees. When I know this triangle, I actually know this other one on the other side because those are going to be congruent. So I could go ahead and just fill this in. This is 50, and these 2 are both 65. So I'm already halfway there. To find those other triangles, I would look at these 2 angles here in the middle are going to be supplementary. So I know that this one is 130, and this one here would also be 130 because those are vertical angles. And then the last ones, I have to remember that these are the same. So this is where you can take 180 minus 130. So those two are going to add up to equal 50. So if you divide that by 2, that would make each one of those 25 degrees. So I did say that there's more than one way that you could go about this. This is one of the ways. Another way I could do this is both of these angles in the corner are both going to have to add up to 90. So another way I could have found that that was 25 is I could have taken 90 minus 65 to get 25. You have some options for this, kind of just depending on what it looks like. For this next part, if they want you to find these different segments, you could have all sorts of things written out. It might be something like, I don't know, this part here, let's say MP is 7x plus 8, and let's say that PL is 8x minus 3. Well, if that is the case, and if this is a rectangle, you know that those diagonals are congruent, and you actually know all 4 parts of these are congruent also. So I could set 7x plus 8 equal to 8x minus 3, and I could just go ahead and solve that by subtracting 7x and adding 3. So x equals 11. If you then had to maybe find the length of, let's say, JL, well, if x equals 11, you could take that and plug it in here. So 8 times 11 is 88 minus 3. This segment would be 85. And if I wanted to find JL, I would just say, okay, both of those are 85, so that would be 170 in length, because I would have to find the whole thing. They could ask you for a whole variety of questions. They could ask you about PK. If they asked you PK, that would be 85. Just make sure you read the directions really carefully and answer the question that's being asked. Okay, you guys know the deal for this one. If you could go ahead and pause the video quick and graph this, we'll do it together in just a minute. Okay, so I actually have 2 different questions going on here with the one graph. In the directions it says, this quadrilateral PQRS has these vertices. Determine whether it's a rectangle by using the distance formula. So it's not just a yes or no question. It actually wants you to go through and use the distance formula to say that it's a rectangle. The problem is that if you just go through and see how long these sides are, just knowing that these sides are congruent or those sides are congruent does not necessarily make this a rectangle, because that's also a property of a parallelogram. So even though that is like kind of the main property we're used to thinking of for a rectangle, that doesn't have to make it a rectangle. It could be a parallelogram. So I'm going to go through and I'm actually going to show the length of the diagonals. And if those diagonals are congruent, that's what's going to make this a rectangle. So I'm going to find the length of the diagonals. And this is actually what carpenters and people that are in construction use. If they're trying to like frame out a window or a doorway for a building, they'll make sure that it's perfectly rectangular by measuring the diagonals, because again, if you have it just even a little bit off, if you're just measuring these and these distances, even though like you might be kind of eyeballing it, it doesn't necessarily have to be exactly a rectangle. And my husband and I, we've done a lot of work in our house. We've had issues with things not being like squared up or just right. And it does not make things easy when you're trying to like put in doors or windows and they're not perfectly square. Okay, so again, what I'm doing is I'm finding the length, let's say, of QS first. So the x values for QS, I am going to take 1 and -7 and find the difference between those. and negative 1 and 0. So this is going to be 8 squared plus negative 1 squared. So 64 plus 1, it's the square root of 65. And it doesn't matter if you change that to a decimal or not. I'm going to just leave it like that. It's about 8.1 if you do want to change it though. So I have PR, and I'm finding the distance for that one to make sure that these diagonals are in fact equal. So subtracting the x values and subtracting the y values. So for P, we have negative 5, and R is negative 1, and 3 and negative 4. So again, I know I'm just kind of assuming we're good with this now. If you need to go back and review, go ahead and do that. We have negative 4 squared, and this here would be 7 squared. So for this one, it's the square root of, this is 16 and 49. So that is also the square root of 65. So because those diagonals are the same length, I can say yes, this is a rectangle. And I'll just put down because diagonals are congruent. So kind of like the last lesson, you won't have to do both of these things for each question. This one here, the directions would specifically say use the distance formula. For this one, it's asking us to use the slope formula. Well, what I could do for that is the slope of these lines should be opposite reciprocals, because if they are in fact perpendicular, then they would have those right angles for the rectangle. So I want to show that all of these lines are perpendicular to the line that's adjacent or right next to it. So I have to calculate the slope of each of these. So if I find the slope of SP, you can either just count it out because it's already on the graph or use the graph formula. I'll go ahead and count it out. So it's going up 3 and over 2. So the slope of SP is 3 over 2. Let's find the slope of RQ at the same time. It's going up 3 and over 2, which seems right because it is a rectangle, and rectangles, the opposite sides are parallel, just like any parallelogram. Okay, now let's find the slope of SR. So for SR, it's going down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So the slope of that one is negative 4 over 6, or if I simplify it, negative 2/3. The slope of PQ is the same, negative 4 over 6, or negative 2/3. So what you would want to say here after you found this is you would want to say that the adjacent sides are perpendicular. So that would let you know that yes, it's a rectangle. So I know this is not on everybody's paper. If you wouldn't mind just drawing it in quick, a rectangle with these diagonals. I forgot to do an example like this, and I just wanted to help you out and show you. If I have this, and I know that these different angles, let's say that this angle here is 2x plus 4, and that's referring to this angle. And let's say I know that this other angle is 7x plus 5. I don't know that those are the same, and actually if it's just a rectangle, they're not going to be the same. But I do know that this would have to be a 90-degree angle. So the way you would solve something like this is you would just add those two angles up and set it equal to 90 degrees. So we have 9x plus 9 equals 90. It's a lot of 9s. 9x equals 81, or x would equal 9. And then depending on if the directions ask you to plug it back in, you could do that and find those different angle measures. So I hope this helps a lot, and I look forward to helping you guys in class.